Let's have a look at aspirin and penicillin. This is Dr. B, and here are the chemical structures. Let's note a couple of differences. One, this is a far simpler structure. This is aspirin here, orthoacetyl salicylic acid. Two, there's no chiral centers here, but there's a lot there. Three, I see one hydrophilic moiety here. That OH, doesn't that not remind you of water, H2O? Here we have a couple, meaning this one may be more water soluble. This one certainly looks like it would be a real bear to synthesize. I see several chiral centers. I see a fused ring. I worry about this thing having a lot of ring strain and wanting to open up, things like that. Anyhow, let's take a look at the history of aspirin. Even if you go back a couple thousand years ago, the lead was there. It was recognized that chewing on a willow branch could help relieve pain. I don't know if I'd recommend that next time you go hiking in the woods. But it was eventually determined by the time some equipment showed up that the active ingredient was known as salicylic acid. However, it had a lot of stomach pain associated with it, so I believe it was Bayer that formed the methyl ester. No, I'm sorry. Yeah. See, we're reacting in carboxylic acid with an acid anhydride. This is acetic anhydride. That will react with the alcohol, in this case this phenol. So they turn this phenol, which is just a alcohol attached to an aromatic ring, directly with this substance, and that helped reduce some of the stomach pain associated with it. But to deal with it even better, they took that carboxylic acid and they converted it in the 1900s into the sodium salt. This helps make it a little bit more better tolerated, and this is perhaps the most common commercial application right here. This is bufferin, aspirin, all that stuff. Okay, so that's a little bit about the history. Is it hard to make? Oh no, you can do this in a high school lab. What type of drug is it? Well, it's used for pain, so we call that a painkiller, or technical term, an analgesic. In order to differentiate it from some painkillers that are steroids, we call this an NSAID, meaning a non-steroidal. It's definitely not a steroid structure. A steroid structure has like 5 fused rings in it. And it's an anti-inflammatory. It's helped to reduce inflammation. The primary target is to influence a pain receptor if you can, and I don't think these things do it all. They go through a different receptor target, which in this case is the cyclooxygenase enzyme. This was all discovered after the fact, right? But the prostaglandin biosynthesis has several steps that your body goes through, including one reacting with this enzyme. It's been determined through, I'm sure, a lot of research that aspirin influences the cyclooxygenase part of this biosynthesis, and the activity is recognized that way, and the observed activity is particularly strong in the realm of inflammation. It's an anti-inflammatory. Okay, good. Now let's take a look at penicillin. Between 1870 and 1930, it was observed that various types of toxic drugs can be used as antibiotics, but they were nasty. Arsenic, industrial dyes, sulfonamides, lots of side effects, but at that point it was the only way to deal with infection. Particularly a fatal one was septicemia, where if you got shot or something deep into your body, you were going to go septic, and there was almost nothing to deal with that. In 1928, however, it was observed that the mold Penicillium notatum did kill bacteria without killing humans or having too much in the way of side effects. This was a big deal, and there's lots of apocryphal stories about how that happened. In 1941, the active ingredient from this bacteria was isolated, and this led to penicillinases that were destroyed by this substance or could not act. But from 1950 to present, something bad happened, right? And that was that, sure, we've got an antibiotic, but the penicillins evolved. And so the drugs to treat them had to evolve, from penicillin to methicillin to oxacillin to, perhaps you recognize amoxicillin. Any parent probably would. But This is not a good thing necessarily. The bacteria are becoming drug resistant. Is it hard to make? Yeah, it would be very hard to make. This thing has a lot of chiral centers, and it would be a challenging synthesis. However, since it occurs naturally, you can just make it by fermenting natural substances. The class of drug is called an antibiotic. The primary target is the bacteria. And if you look at what it's doing specifically, it's found that it inhibits the enzyme transpeptidase, which would be a bacterial but not a human enzyme. This is why it would not harm humans. And so the bacteria can't form cell walls, and it's rendered inactive. So this is a very effective way to come up with an antibacterial. This is a look at aspirin and penicillin.